Hello friends, let's know about microprocessor 80386, the third generation Intel microprocessor. Our agenda is to know salient features of 80386, types of 80386, architecture of 80386, register organization of 80386. An introduction of 80386. It is the first 32-bit version of 8086 family, that is, before this all microprocessors are of 16-bit. It has offered compatibility with 8086, 8088, 80286, etc. It was launched in October 1985, but full function chips were first delivered in the third quarter of 1986. It was not used in personal computers so long, but Intel and others had continued making the chip for embedded systems. It was used in aerospace technology. History of 80386 microprocessor. The Intel 80386, 80386, also known as i386 or just 386, is a 32-bit microprocessor introduced in 1985. The first versions had 275,000 transistors and were the CPU of many workstations and high-end personal computers of the time. The first computer to make use of the 80386 was designed and manufactured by Compaq and marked the first time a fundamental component in the IBM PC compatible de facto standard was updated by a company other than IBM. Salient features of 80386. It supports 8 1632-bit data operands. It has 132 pins. It has 32-bit internal register. It supports physical address of 4 GB, that is 2 to the power 2 into 2 to the power 30 bytes. So we need 32 bits to address 4 GB location. It supports maximum segment size of 4 GB. It supports virtual address of 64 terabyte, 4 GB segment into 16 KB segment. It operates in 3 different modes: real, protected, and virtual. Memory management unit provides virtual memory, paging, and 4 levels of memory protection. It has low cost and low power consumption. It used clock frequency of 20, 25, and 35 megahertz. It operates in pipeline mode, that is, it sends the address of the next instruction or data to the memory prior to completing the execution of current instruction, so that memory system to begin fetching the next instruction or data before current is completed. This increases access time, thus reducing the speed of memory. Interrupts in the 80386 microprocessor have been expanded to include additional predefined interrupts in the interrupt vector table. The 80386 is operated in the real mode, 8086 mode when it is reset. Types of 80386. We have 3 types of 80386. First is 80386DX, which is used for floating point capability. Second one is 80386SX, which has 16-bit data bus. Third one is 80386SL. Several power management options included. Differences between 86DX and 86SX. First difference between two is 80386DX has 32-bit address line and 32-bit data lines, while 80386SX has 24-bit address lines and 16-bit data lines. Using 32-bit address lines, 80386DX can access 4 GB of physical memory. Using 24-bit address lines, 80386XX can access 60 MB of physical memory. Third difference is 86DX has high cost and power version than 86SX, and 80386SX is low cost, low power conversion. Features of 86SL. Low power microprocessor with power management features with 16-bit external data bus and 24-bit external address bus. The processor included ISA, bus controller, memory controller, and cache controller. The internal architecture of 80386 is divided in three parts. First is CPU, second MMU, and third one is bus control unit. In this figure with red border is CPU, that is central processing unit, and with blue border is MMU, which is memory management unit, and with black border is bus control unit. Oh. As I tell, there are three sections in architecture of 80386. First is central processing unit, second memory management unit, and third bus interface unit. Central processing unit is further divided into two units, that is execution unit and instruction unit. Execution unit has a general purpose register and special purpose register. We will learn about registers in further slides. These registers are used for handling data or calculating offset addresses. Instruction unit. The instruction unit decodes the opcode bytes received from the 16-byte instruction code queue and arranges them in a 3-instruction decoded instruction queue. After decoding them, pass it to the control section. For driving the necessary control signals, the barrel shifter increases the speed of all shift and rotate operations. The multiply divide logic implements the bit shift rotate algorithm to complete the operation in minimum time. Even 32-bit multiplication can be executed within 1 microsecond by the multiply divide logic. MMU, the memory management unit, consists of segmentation unit and paging unit. Segmentation unit allows the use of two address components, segment and offset, for relocatable and sharing of code and data. Segmentation unit allows segment of size 4 GB at maximum. The paging unit organizes the physical memory in terms of pages of 4 KB size each. Paging unit works under the control of the segmentation unit, that is, each segment is further divided into pages. The virtual memory is also organized in terms of segments and pages by the memory management unit. A bus interface unit. The bus unit is the interface to the external devices. The bus interface unit provides a 32-bit data bus, a 3-bit address bus, and the signals needed to control transfers over the bus. In fact, 8-bit, 16-bit, and 32-bit data transfers are supported. 80386 has separate 4 pins for its address and data bus lines. This processing unit contains the latches and drivers for the address bus, transceivers for the data bus, and control logic for signaling whether a memory input, output, or interrupt acknowledgement bus cycle is to be performed. Register organization. The 80386 has 8 32-bit general purpose registers, which will be used as either 8-bit or 16-bit. A 32-bit register, known as extended register, is represented by the register name with prefix E. Example, a 32-bit register corresponding to AX is EAX. Similarly, BX is EBX, etc. The 16-bit registers BP, SP, SI, and DI in 80386 are now available with their extended size of 32-bit and are named as EBP, ESP, ESI, and EDI. AX represents the lower 16-bit of the 32-bit register AX. General data address, general data and address. इसमें AX, BX, CX, DX, SI, DI, BP, SP. These all are general purpose registers. There are segments code segment, CS is code segment, SS stack segment, DS data segment, ES extra segment, FS is GS we use in 80386 for extra segments. We use them as extra segment. Instruction pointer and flag. We have instruction pointer which points to next instruction in the instruction, and flag. BP, SP, SI, DI represents the lower 16-bit of their 32-bit counterparts and can be used as independent 16-bit data registers. The 6-segment registers available in 80386 are CS, code segment, stack segment, data segment, extra segment, FS and GS. The code segment and stack segment are the code and the stack segment registers respectively, while DS, ES, FS, GS are 4 data segment registers. A 16-bit instruction pointer IP is available along with 32-bit counterpart EIP. Flag register of 80386. The flag registers of 80386 is a 32-bit register. Out of the 32 bits, Intel has reserved bits D18 to D31, D5 and D3. While DI is always set at 1, 2 extra new flags are added to the 80286 flag to drive the flag registers of 80386. The VM and RFVM is a virtual mode flag. If this flag is set, the 80386 enters the virtual 8086 mode within the protection mode. This is to be set only when the 80386 is in protected mode. In this mode, if any privileged instruction is executed, an exception 13 is generated. This bit can be set using IRET, which is instruction return instruction, or any task switch operation only in the protected mode. The next is RF resume flag. This flag is used with the debug register breakpoints. It is checked at the starting point of every instruction cycle, and if it is set, any debug fault is ignored during the instruction cycle. The RF is automatically reset after successful execution of every instruction except for IRET and POP-F instructions. Also, it is not automatically cleared after the successful of jump, call and enter instruction, causing a task switch. These instructions are used to set the RF to the value specified by the memory data available at the stack. Segment descriptor register. These registers are not available for programmers. Rather, they are internally used to store the descriptor information like attributes, limit and base address of segments. The 6 segment registers have corresponding 673-bit descriptor register. Each of them contains 32-bit base address, 32-bit base limit and 9-bit attributes. These are automatically loaded when the corresponding segments are loaded with selectors. Control register. The 80386 has 3 32-bit control registers, CR, CR2 and CR3. To hold global machine status independent of the executed task. Load and store instructions are available to access these registers. System address registers. 4 special registers are defined to refer to this descriptor table supported by 80386. The 80386 supports 4 types of descriptor table, that is global descriptor table, interrupt descriptor table, local descriptor table and task state segment descriptor table. Debug and test registers. Intel has provided a set of 8 debug registers for hardware debugging. Out of these 80 registers, DR0 to DR7, 2 registers, DR4 and DR5 are Intel reserved. The initial 4 registers, DR0 to DR3, store 4 program controllable breakpoint addresses, while DR6 and DR7 respectively hold breakpoint status and breakpoint control information. 2 more test registers are provided by 80386 for page caching, namely test control and test status register. Thank you.